Hi everyone, welcome to this video on the final lesson of the Human Body Part 2 scheme. This is about diabetes. So this lesson builds on what was covered in the previous lesson on insulin and blood glucose. And I think it's worth beginning just by recapping the story that you told last lesson on how insulin controls that blood glucose concentration. Now, you may wish to do this as a kind of prerequisite knowledge check on whiteboards and get students to retrieve it. Depending on how that goes, you may wish to then go through it again, or you could have one pre-prepared or return to the diagram that you had previously in your book. But I think it's really useful to do two diagrams, or in fact 3 diagrams, as we'll see in a minute, side by side here, because that those side by side diagrams are really helpful for scaffolding students' thought and getting them to write about what we want them to write about, because it shows them, okay, if one thing happens, then this is what happens, they can write that. This is the normal case, let's say, whereas if the other thing happens, then it goes down like that. The side-by-side layout can be really helpful for structuring their thinking. So in this case, I've got the normal case over here. So this is exactly, if I just zoom out a bit, this is exactly what we did last time. So if a person eats some chocolate, they get a high blood glucose concentration. The kind of desired response, I suppose, of the body would be that the pancreas produces insulin. Blood glucose is converted to glycogen, stored in the liver, it exits the bloodstream, and hence the blood glucose concentration returns to normal. Now, what we're going to do then is talk students through a couple of cases where this doesn't quite work. So if I move over here, I'm just going to cover that one actually. So let's look at the second case. So in this case, what can happen is that a person eats a bar of chocolate. So they've got a high blood glucose concentration. That's nothing new. That's exactly what we've seen before. But for some people, for genetic reasons, their pancreas stops producing insulin, I mean, typically, from my knowledge of this, and actually I would have to check on this, but from my knowledge of this, what we're talking about here is type 1 diabetes, which typically develops during teenage years. So it's at some point the pancreas stops producing insulin. It may happen earlier. I would need to check that. But consequently, because no insulin is being produced, there is nothing to stimulate glucose to be converted to glycogen and stored in the liver. The outcome being our blood glucose concentration stays high. Now, note, the way I've organized this is I've not started with type 1 diabetes. I've started with the process. And what I'm going to then do, once I've finished explaining this part, is say, so this here, this is the cause of what we call type 1 diabetes. So I'm going to put type 1 diabetes. And I might put something about that being genetic. So there's not a lot you can do if your body stops producing insulin. What you can then talk to students about is how you treat that. Well, this can be treated by injecting insulin, and this is why people who have type 1 diabetes will often be seen after a meal to be injecting. You can then talk them through about the dangers of injecting insulin. Sometimes if a bit too much insulin goes in, a bit too much glucose exits the bloodstream, then they have a kind of hypoglycemic moment and the blood sugar crashes and then they need to eat a chocolate bar. But you can talk students through all of that stuff and why that method of treatment works for type 1 diabetes. Because the problem is they're just not producing the insulin in the first place. But medical technology is wonderful and it has allowed people to live with type 1 diabetes for their whole lives. With some inconvenience, but actually they can do most things without too much concern. Then there's another case here that we're going to talk about, and again, it's helpful to have had that previous one. What's the body supposed to be doing, and then we've got a comparison here. So this is the case, and you can talk students through why this might happen in terms of obesity being a risk factor and essentially eating too much sugar. But when this person eats the chocolate bar, we've got the high blood glucose concentration, as we've seen. In this case, their pancreas produces insulin, but essentially because they've been hammering so much sugar into their blood for such a long time, essentially the cells just stop responding, and even though the insulin is there, the glucose just no longer gets converted to glycogen. So again, the glucose does not exit the bloodstream, and therefore the blood glucose concentration stays high. And again, it's hard for me to show on the visualizer, and you know, this is a logistical challenge as well for when you're teaching this in class. But if students have these diagrams available, and they see that side by side nature to it, then they can really see how each of these cases is different. And of course, this one is distinct from type 1 diabetes. This part here, the fact that the cells have stopped responding, this is the hallmark of type 2 diabetes. Again, I'm going to explain the concept first and then put a name on it at the end. And I will put that there are risk factors for this, and I'll stress to students from a kind of, I suppose from a public health point of view, that obesity is the major risk factor for type 2 diabetes. And that then leads to the further point that you can't treat type 2 diabetes like you can treat type 1. So type 1, the problem is that the pancreas isn't producing enough insulin, as we saw. If I zoom out, and hopefully we can see both on one screen. So with type 1, the problem is not enough insulin. Well, you can counter that by injecting, and you can kind of artificially do the pancreas's job, and live in a way that without too much inconvenience. Whereas type 2 is a bit more problematic because you can't get the cells to start responding again. Once they've stopped responding, that's it, game over. And I think this is really worth stressing to students, that actually, if you develop type 2 diabetes, then the only way you can deal with that, you can't kind of treat it per se, you just have to control it through diet and essentially just stop eating those foods which give you these big sugar spikes. So worth emphasizing that to students. I suppose the last thing to say is that with both of these, there are genetic, so type 1 is obviously a genetic condition, whereas type 2, some genetic groups are more at risk of developing type 2 diabetes, and that's worth emphasizing as well. Again, not just from a science point of view, but from a public health point of view too. And I suppose the last thing that I should say is that throughout this, it's worth framing what you're talking about with this idea of stimulus and response. So in all of these cases with lots of little red dots, it's quite overwhelming actually looking at the screen, so apologies for that. But in all these cases with blood glucose, the stimulus is changes to the blood glucose concentration. And the response in each case is related to, as we saw in the previous lesson, insulin or glucagon. And what you can say here is, again, framing it in terms of that language of stimulus and response, which is the big idea running through this sequence of lessons. How you can frame this is when the body's response mechanisms no longer work in the way they're supposed to. And that's a really good example of, it's another way of illustrating, I suppose, that big idea through this example of the disease of diabetes. Anyway, that is the end of this scheme of work. In the next scheme of work, we will be looking at forces and space.